Okay, I think we've got people coming in. Hello and welcome to everyone that's joining. My name is Miss Aisha Zahir. I'm a maths teacher and I also tutor for high school, so Key Stage 3 and Key Stage 4 maths. And today what we're going to look at for this live session is higher topics. So I've just grabbed a higher GCSE mini test from Maths Uni. You can also go ahead and download that and complete it with me, or you can be grabbing a notepad and pen, or you can simply just be listening and taking mental notes for these topics. Now, I'm aware that the GCSE maths have already passed, but this is for just pure revision for year 10. If you're in year 10, or even if you're in year 9, you might have been exposed to some of these topics, okay? So you can go ahead and take part. And what I'm going to do is begin with the first question over here. And if at any point you are confused by anything, please let me know in the comments, or if you want to share anything that you know about any of these topics and questions, then also share that as well. Okay, so I'm going to begin with question number 1, which is a solving question. Let me just see if I can zoom in. Welcome to everyone that's joining. Oh, is it gonna let me zoom in? Yeah, so I've managed to zoom in slightly. That's a bit better. Okay, so it's asking us to solve 2 times by x plus d plus 9 times by x plus 7 equals 1. So that's algebraic fractions. Okay, and we've got to solve for x. Anybody know how to do that question before I begin? What might be the first step to solving this sort of question? Any ideas from anyone that is watching? Okay, so I'm just going to begin, and if you would like to take part, anyone that's joining, please do so in the comments. So the first question, what we'll do in algebraic fractions is try and make the denominator the same, okay? So it's the same rules that apply for adding and subtracting normal fractions. We're making sure that the denominators are the same before we can do any adding. In this case, because it's an algebraic expression, we're going to try and times the first fraction, top and bottom, by x plus 7, okay? And the bottom and the second fraction, to make that identical with the first, the denominator, we're going to times the top and bottom by x plus 3. Okay, and now I'll just show you in the next line how to actually go ahead and do that. So that means I'm going to do 2 over x plus 3. Okay, I'm going to times the bottom by x plus 7, like I've mentioned there, and I'm also going to times the top by x plus 7. Now there is a shortcut sort of way to do this all in one step, but I'd like to show everyone the step by step method so that you know exactly what's happening. Okay, make sure you're double tapping if you're finding this helpful, and you know, if you are understanding it, and if you've got any sort of questions, let me know in the comments. Okay, and then the second fraction, we're going to times the top and bottom by x plus 3. So by that I mean the numerator and denominator. So we've got x plus 7 times by x plus 3, and it all equals to 1. We keep that 1 there, okay? We don't get rid of that, and nor do we multiply that by anything, okay? Because it's on the other side of the equation. So we are not really going to do anything with this one for now. We're just going to focus on making our denominators the same. Well, now you can see that they are both the same. So what I'm going to do now in the next line is just write all of this over one fraction, okay, because it is the same, which by that what I mean is the following. So I'm going to do 2 times by x plus 7 plus 9 times by x plus 3 all over x plus 3 times by x plus 7. Okay, now you might notice that in the first line over here, I've just got x plus 7 first, but in the first fraction I've got x plus 3 first. Well, that doesn't, the order when you're multiplying doesn't really make a difference. They're still both identical, okay, because multiplication is commutative. So that's why, okay, and I've just written it all over one common denominator now. And now it's just a case of simplifying your numerator, and then doing a bit of rearranging to then solve for x. Okay, now that I've run out of space here, I'm just going to do that on a separate piece of paper. So we left off at 2 times by x. Let me see that. Yeah, x plus 7 plus 9 times by x plus 3 all over x plus 3 times by x plus 7 equals 1. Okay. When is GCSE paper, please? So welcome, Safa. I believe the GCSE papers have all finished, unless you live in maybe a different country, I'm assuming. But in the UK, all the 3 papers have happened already. So this is for purely if you're year 10 or even year 9 and you're really interested in doing a bit of, learning a bit of maths. Or we're revising for it. So if you're in year 10, I mentioned it would be helpful for you. Okay. If you are in year 10, it will be very helpful for you. But you know what you can do in the comments, if you would like me to do a topic that you're interested in, depending on whichever year group you're in, you can always comment or inbox me with a topic request. But I ideally, you know, pick the topic requests based on people that are my subscribers. So if you want to become a subscriber, one of the benefits are that you'll get to pick the topic of my next live session. Okay, so please click the subscribe button, guys, below, or you might see at the top, okay, of your screen. And if you do that, you get to join my subscribers community. So and there are many perks to that which you can read, you know, in the information box as well. So I'm going to go ahead and finish off this question. So the numerator is just a case of us expanding our brackets as follows. So 9 times by everything inside my bracket and 2 times by everything inside my bracket. So that means I'm left with 2x plus 14 plus 9 times by x is 9x plus 9 times by 3, which is 27. Okay, all over x plus 3 and x plus 7 equals 1. So now I'm just going to tidy up my numerator and also move my denominator over to my other right hand side. Okay, now you'll see what I'm doing now. So if I tidy up the top, I'm going to collect my like terms. So that means 2x and 9x are like terms, and that's a positive 9x. I'm going to put a box around my second set of like terms, which is my 14 and my plus 27, as follows. So that means I've got 2x plus 9x is 11x, 14 plus 27, so that becomes 27 plus 10 is 37, plus 4 becomes 41. Okay, this all equals to 1. But what I'm going to do now is take my denominator and move it to the other side, okay, to my right side. So that now becomes x plus 3 times by x plus 7, okay. If any of this is confusing anyone, please feel free to leave that in the comments, okay. If you're understanding so far and it's all going good, just keep double tapping the screen, guys, and also share the live session with others that you know will find this helpful, especially if they're in year 11. So now it's a case of sorting out my right hand side, okay. So I'm going to leave this left side as it is and expand my second set. So I'm just going to expand my double brackets as follows by drawing these arrows. There are many ways in which you can expand double brackets. I may have put a video on my channel, on my page, or definitely on my YouTube page as well. You can check that out if you'd like a bit of reminder about how to expand double brackets. Now the one I know is outside my double bracket, but we're not going to times that one by you know, it doesn't really make a difference, so we can just ignore the 1 for now, okay. 1 times by anything is going to be whatever that thing is. So in this case, what these double brackets are. Okay, so if I do x times by x, it becomes x squared. X now times by plus 7 becomes plus 7x. 3 times by x becomes plus 3x, and then 3 times by 7 becomes plus 21. Now a case of tidying things up. Okay, so it becomes x squared. I'm going to collect my like terms. 7x plus 3x is plus 10x, and I've still got plus 21. Now what I'm going to do is yeah, there are two different ways in which I can do this. Is I'm just going to move everything onto the other side. Okay, get everything on one side so that I can then cancel things out and eliminate. So looking for another piece of paper. Okay, so there is again two different ways in which we can do this. So we could move this quadratic onto that side, then things will become minus. Okay, or we could move this 11x plus 41 on the other side. But what I'm going to do is just move 11x plus 41. So I'll rewrite it onto my right hand side. Okay, so this side becomes 0. And now on my left side, I've got x squared plus 10x plus 21. And whenever you're moving something to the other side, you're always doing the inverse of what's happening. So because it's a positive 11x here, I'm going to make it negative 11x. And because it's positive 41, I'm going to make it negative 41 on the other side. Okay, so now all of this is equal to 0. Okay, so x squared, and now what I'm going to do is just collect my like terms. So I've got positive 10x and negative 11x, and plus 21 and negative 41. Okay, these are my two sets of like terms, and what I'm going to do is just collect them together. So I've got x squared plus 10x minus 11x becomes minus x, plus 21 minus 41, well, that would become minus 20. If I'm not wrong, yep. And that is that. Okay, so the quadratic is just x squared minus x minus 20 equals 0. Now it's a case of actually factorizing your quadratic. Okay, so any ideas how we might do that? Welcome to everyone that's joining. Oh, I'm so sorry, Safa, I missed your comment. You said you are in year 14 ICL. Oops. What does that mean, I wonder? Welcome to everyone that's joining. We are just going through this GCSE mini test. Okay. Oops. If you'd like to take part, please double tap and also post in the comments any suggestions that you've got, anything you want to say with regards to the paper that I'm doing. So let me just finish this off. So if we are factorizing this, it becomes, we need to find two numbers at times to give minus 20 and add or subtract to give minus x. So the pair that comes to my mind would be minus 5 and positive 4. Okay, because minus 5 times positive 4 will give us minus 20. But when you add these two together, you would be left with minus x. Okay. So I'm now going to go and put these in brackets. So I've got x minus 5. Sorry, not x minus 5. X squared minus 5x plus 4x minus 20. And that is all meant to be equaling to 0. And now what I'm going to do is just put this in brackets. So I've got x times by x minus 5, x minus 5, and the plus 4 is outside my brackets. Okay, and now if I go ahead and actually solve this, let me get my brackets first. So it's x plus 4 and x minus 5, okay, equals 0. So if I solve for x, I get x is equal to minus 4 and x is equal to positive 5. Okay, so that is my answer for that question. That was quite a long question, solving algebraic fractions. Okay, and it is usually a tough one as well. Welcome to everyone that's joining. I am doing a maths, GCSE maths live. Okay, so far we've just done question 1. If you like to carry on watching, please keep double tapping the screen, and also share in the comments if you've got any sorts of questions about any of this. Okay, I am now going to just do question 2 before I might be wrapping up, because I can see it is time for Isha. Welcome to everyone that's joining. Please double tap the screen as you are, and any suggestions or any comments you've got or anything you want to ask, please leave it in the comments. So does anyone that's watching know what question 2 might be about? So we've got a triangle. We're trying to work out the size of this angle. Okay, and we have been given one angle as well as 2 different sides lengths. So any ideas what formula we might be needing to use, or what rule might be applied over here? I feel like everyone is awfully quiet today. Okay, I'm going to end this now, and I will probably continue it tomorrow or at another day. If anyone's got any questions or any suggestions for next live sessions, remember you can click the subscribe button and become a subscriber to get all those perks. Okay, I'll see you all in the next live session.